inequality and then solve it. So let's take a quick moment to read it. The width of a dog's exercise crate is 5 feet less than the length. Okay, so we have a rectangle, we have the length, we have the width, and it says the width is, right, the width is 5 feet less than the length. So remember when we learned 5 feet less than, that means that it goes at the end. So the width is actually L minus 5. The width is 5 feet less than the length. The perimeter is no more than 16 feet. So the perimeter is no more. It can be 16, but it can't be any more. So less than or equal to 16. All right, then let's go ahead and write our expression for perimeter, which is at all sides, or 2 widths and 2 lengths. So 2 lengths plus 2 widths, but remember my width is being represented by 5 less than the length, so L minus 5 is less than or equal to 16. As you can see, we went ahead and distributed the 2 into the L and the negative 5, and then combined like terms. Now we're going to add the 10, divide out the 4, and we get L is less than or equal to 13/2, or 6.5 feet. So any value for L that is 6.5 or smaller will work for both of them. Next, let's talk about compound inequalities. So this is when we have more than one thing going on in the same problem. So a few things for you to think about before we even tackle some of these. We need to remember and shades in, and go ahead and highlight that or circle that, and or shades out. You'll know what I mean in a moment. And the other thing we want to remember is that we never write an or statement as a linked inequality. That's one thing that you'll also see below when we start solving these.
Okay, so let's solve a compound inequality then. So compound inequality just means it has the word and or between it. What we can do is we can just solve them separately, and then we're gonna graph them and see how that looks different on our graph. So for the first one, I wanna solve for A, so I'm gonna divide off the 2. A is gonna be less than 2 because 4 divided by 2 is 2, so that's it's part of my solution. So then for the next one, just solving really quickly, negative 3a is less than 3. This is where alarms should be going off, because right here, when I divide by negative 3, what should we be thinking? I hope that you're saying flip that inequality. I'm going to flip this inequality sign. So it was less than, but now I'm gonna make sure I write it as greater than. Be so careful, be on the lookout for that. It's only because I was dividing by a negative number. So a is greater than negative 1. So far I've got this kind of solution. A is less than 2, and at the same time, a is greater than negative 1. So when I go to graph this, I'm gonna do something a little bit different. I'm gonna put my 0 on there just like we did on the front, but I'm gonna grab a pencil really quick just because it's our first time graphing a compound inequality, so I'm gonna be careful. So I'm gonna just graph one at a time, really nice and light in a pencil, because I'm going to erase some stuff in a second. So a is less than 2. So 2 would be right about here. A is less than, so that's an open circle. Less than 2 is gonna go this direction. I'm just gonna draw it real light, pointed that direction. You can draw it, point it out if you want, okay? A is greater than negative 1. Negative 1 would be right here. A is greater than it, so again, open circle, and it would be pointed this direction right here. This looks so funky. We haven't had something look like this yet, but this is what Mrs. Peart was talking about before when she said and shades in. And statements mean that my solution needs to satisfy both of the inequalities. My solution set needs to satisfy both of the inequalities here. I need to be less than 2 and I need to be greater than negative 1. So my solution's actually only the overlapping area here. So when I draw my actual answer or my solution set on my number line, I'm gonna draw it like a bar, kind of like a dumbbell, from negative 1 to 2. Anything else that was extra pointed off does not satisfy both of the inequalities that were part of my solution. So I cannot include all this stuff that's less than negative 1 or all this stuff that's greater than 2, because that violates one of these two things here. So this is my solution graphed. So now I want to come up with a really nice way to state my solution algebraically. Well, you can kind of see x is all these possible numbers in between here. I'm gonna write that word down. So when I write my answer, I almost wanna make it look like x is between two things. So if x is in between negative 1 and 2, I'm gonna complete that with inequality symbols. So over here, oh no, it was an a. So let me fix that. A, and a is in between. So if a is less than 2, I'm just gonna copy that inequality symbol right there. If a is greater than negative 1, Well, right here, -1 comes first. So if A is greater than, I'm going to make sure that my inequality symbol still opens to the A. So I'm just flipping that inequality symbol because I flipped the order from the original solution set.
Looking at B, now that we kind of know how to write an AND statement as a linked inequality, when I look at B, I already know that it's an AND statement. The nice thing about writing it this way is that when I go to solve it, I can just do it all at one time. There's 3 sections. So when I add 2, because I have to undo that first, add it to all 3 sections. And then the same idea when you divide the 5, divide all 3 sections. Now we're going to go ahead and graph. So I'm going to put the 0, I'm going to put the 1. Oh my gosh, what about 9/5? Well, 1 4/5, it's a little less than 2. So I'll go ahead and put a 2, and then I'm going to kind of put a little mark and say 9/5 so I know which one I'm talking about. Now the other thing, did you notice my mistake? It's 1 less than x less than or equal to. I forgot to bring that equals to down. So slow down and check your work because we all do that sometimes. The equals to, I want to put a big dark circle, but the 1, I make it like a swimming pool. It cannot equal 1. And then let's make it like a dumbbell. It's shaded in and shades in between.
Okay, moving on to C. C is going to be our first OR compound inequality. We don't do any of the algebraic work differently. It's just going to affect the way our solution set looks in our final answer. So let's start solving these just like we were solving the other ones. So take a moment. I'll solve the first one separately than the second one. Then I'm going to divide by this -2 to get m by itself. And I hope you have that alarm going off in your head like I do in mine. What do I have to do when I divide by that negative sign? I got to flip my inequality sign. So first part of our compound solution here is m is less than -8. Then as I go solve this next one, I get 4m is greater than or equal to -20. Okay, and then I'm going to divide by this 4 here. Okay, I'm going to get -5. When I divide by this 4, do I need to flip that inequality sign? Because I have this negative number on the other side? No, I don't need to flip the inequality sign. It's only when I am multiplying or dividing by a negative, not if just my solution has a negative number in it. So I'm going to say, okay, m is still greater than or equal to on that one, -5. Let's see how this graphs. So let me get my 0 on here. M is less than -8 is going to be the first one I graph. So -8 would be like way over here if my 0 is going to be in the center. Less than is going to be an open circle. Make sure it's obviously open, and then less than, so that could be -9, -10, so I'm going to point it to the left. Okay, then m is greater than or equal to -5. Well, -5 would fall right about there. And then greater than or equal to, closed circle, make sure it's nice and obvious. Greater than or equal to, well, 0 is greater than or equal to -5, so I'm going to make sure I point it in the 0 direction. So notice how this looks different than an AND solution because I don't have that bar like the AND statements where it kind of look like a dumbbell. Instead, I have these little arrows that kind of point the opposite direction. So it's almost like I'm showing off my muscles, right? So OR statements showing off, AND statements look like that dumbbell. So if this is my graphed solution set, I want to make sure I say my answer algebraically correctly. Since my answer isn't trapped in between, if there's no natural way to trap my variable in between these two things, we're not going to try to write our solution as a linked inequality. Instead, we're going to say m is less than -8, or we're physically going to write the word or, m is greater than or equal to -5. That would be my official algebraic solution. What's kind of cool about OR compound inequalities is to be a solution, I only have to satisfy one of these. So if I say, oh, could m be -9? Well, since -9 is less than -8, yes, it could be.
Okay, D, go ahead and pause it, do it, and then I'll come back and I'll check the work with you and see if you need help graphing. So this is interesting. We get m is less than or equal to 7, or m is greater than or equal to 7. So when we go to graph that, we of course put our 0, we put 7, and then it's supposed to equal, so I'm going to totally shade in 7. But the first one says less than or equal to, and the second one says greater than or equal to 7. So in this case, our solution set is all real numbers because every single thing on that number line is shaded. So all real numbers. Do you remember the double bar R for all real numbers? If we wanted to be very specific, we could say m is a real number.